Hello everyone, welcome to Atasia Learning Center. Today we will talk about ES level Cambridge Chemistry, Chapter 1, Moles and Equations. It is about masses of atoms and molecules. These are the learning outcomes for these videos. You should be able to define and use the terms relative atomic mass, isotopic mass, and formula mass based on the carbon-12 scale. Analyze and use mass spectra to calculate relative atomic mass of an element. Okay, about relative atomic mass. As we know that atoms of different elements, they have different masses. Yeah, for example, here we have different kinds of atoms: Cl, oxygen, carbon, hydrogen, helium, and bromine. When we perform chemical calculation, we need to know how heavy one atom is compared to the another one. Yeah, the mass of single atom is so small that it is impossible to weigh it directly. To overcome this problem, we have to weigh a lot of atoms, and then we compare this mass to the mass of the same number of standard atoms. And then scientists choose the isotope carbon-12 as the standard. Yeah, they has been given the mass of exactly 12 units for carbon-12. Yeah, the mass of the other atom is found by comparing their mass with the mass of carbon-12. So on the other hand, that one atomic mass unit is defined as 1 over 12 times mass of isotope carbon-12. So this is called relative atomic mass, or ER. Then it can be calculated using this formula. For example, we need to calculate AR of element Y. So it should be 12 times average mass of one atom of element Y divided by mass of one atom of carbon-12. Standard symbols of element mostly can be generally can be described as this. Yeah, A, Z, X. While X is the element symbol, Z is the atomic number or proton number, and then also equals to electron number, with note that this is the neutral atoms, not ions. Then A is nucleon number or the mass number, or we can say it is a proton plus neutron number. Yeah, for example, this one is sodium 2311. So it means that 11 is the proton number, and electron also 11 because this is neutral atoms. So it means that electron has the number same to the proton number. Then neutron number can be determined by subtracting the mass number with proton number. So it should be equals to 12. Relative isotopic mass. Isotopes are atoms that have same number of protons but different number of neutrons, or same number of protons, different number of nucleons, or atoms that have same number of protons but different number of mass. Yeah, it's kind of similar. Yeah, and we represent the nucleon number as p plus n by a number written at the top left hand corner of the atom symbol. Yeah, for example, 12 20 Ne. Yeah, so it means that this is the isotope neon 20. Yeah, isotope neon with the mass 20. Or we can write down by the atom's name symbol, such as neon 20 or Ne20. Okay, we use the term relative isotopic mass for the mass of the particular isotope of an element on a scale where an atom of carbon-12 has a mass of exactly 12 units. Yeah, we still use carbon-12 as a standard to measure or to determine the atomic relative mass of this isotope. Yeah, if we know both natural abundance of every isotope of an element and their isotopic masses, we can calculate the relative atomic mass of the element very accurately. Okay, to find the necessary data, yeah, it means the natural abundance and their isotopic masses, we use an instrument or the uh, equipment, yeah, some equipment called mass spectrometer. Okay, mass spectrometry. Yeah, these are the diagram, yeah, schematic diagram of mass spectrometry. Yeah, a mass spectrometer can be used to measure the mass of each isotope present in an element, and also we can measure the relative abundance or isotopic abundance. Okay, the first chamber of this part of the instrument is the ionization chamber. Yeah, we have the heated filament will produce high energy electrons, and then we vaporize the sample, and then we so in such condition, the electron with high energy will collide with our vaporized sample or the gas sample. So it will make our sample to have negative charge. Okay, after that, the sample, ionized sample will be enter the next chamber, which is the acceleration chamber. Yeah, it has plates, which is positively charged. So it means that our ions, which is negative ions, will be attracted to the plate. So it will be accelerated. That's why it's called um, accelerated chamber or acceleration chamber. Okay, and then the ions will enter the um, next part of the mass spectrometry. This spectrometry, it is the deflection chamber. Yeah. The ions enter the chamber that has magnetic field. Yeah, as we know that our sample is negatively charged. Yeah, it contains more than one isotopes. They have same charge, but they have different masses. Uh, Charged particles inside the magnetic field will have maybe you learned this in physics. You will have magnetic force. Yeah, this magnetic force will cause them to bend or to deflect into certain angle. Okay, how far they deflect, it depends on the mass of the particle, yeah, because the charge is the same, yeah, all of them become -1 or -2 ions. So it means the one that difference between this isotope is the mass. So the most or the lightest particles will be deflected the most, yeah, because they have less mass, yeah, and then the one with the heaviest will be deflected less than the others, yeah, and then they will arrive at detectors at different time, so we can measure the mass, yeah. Of course, the one will be arrive first at detector is the lightest isotope, and then detector, recorder, and computer will process the data and then present it as mass spectrum. Yeah, these are inside the deflection chamber. Yeah, as you can see here, the green color is the light ions, the blue is the ions that are arriving at detector, and then the purple one is the one with heavy mass. Okay, and then these are the data that we have after we use a mass spectrometer. Yeah, as x-axis we have charge over mass over charge ratio or m over e, and then actually this one is because charge is the same, So it means that they will arrange based on their mass. Yeah, the lightest one will be recorded first, and then the heaviest one will be recorded last. And then the detector also will measure the current they receive when this negatively charged is arrived at detector. Okay, how high the current, as we know here, it presented use y-axis. Yeah, it can be converted or calculated into percentage abundance. Yeah, so the one with the most current will have most abundance. Yeah, then we have the data like this. Yeah, it has been translated, so it means that now the 204 isotopic mass of this lead will be the first one have 2% abundance and so on. Yeah, total they made up to 100%. Then to calculate the relative atomic mass, we follow this method. Yeah, we multiply each isotopic mass by its percentage abundance and then add the figures together, then divide by 100. So we assume that the mass of the isotope is in 100 gram. Yeah, so this is the formula. So ER of PB or lead in this based on the data should be we multiply the abundance with each isotopic mass and then we add them together and then divide by 100. Yeah, the result is ERPB is 207.22. As we know that this AR is the one that written in your periodic table. You can check it. Yeah. So that's why in the periodic table, each element has different. I mean, it has not exact or not a whole number as each AR. Yeah, it means they have like a decimal things like this. Yeah, 207.22. This because of the average of the mass of each isotope they have for each element. Yeah, in this case, for lead or Pb has 4 different elements. Okay, the purpose of using AR, yeah, average AR or average mass of isotope, or we call it AR, is because when we try to react something in laboratory, for example, we need to react this Pb with another one, with another chemicals. If we don't use this average or AR, yeah, it means that in real life that Pb exists as these 4 kind of isotopes with chance of or the ratio between them is as tabulated in these tables. So it means that we need to use the average of masses of these isotopes, or we call it AR. Okay, another example is, for example, we have neon. Yeah, in the spectra of MS, neon has 3 peaks. Yeah, 20 neon, 20 neon has 90.9%, and 21 neon will have 0.3%, and 22 neon have 8.8%. So it's the same formula. Yeah, 90.9 times 20. Yeah, each mass is multiplied by each abundance, and then we add them together divided by 100. So the result is 20.18 as it is written in a periodic table. Okay, after we learn about relative atomic mass, we now learn about relative molecular mass, or MR. Yeah, the symbol is MR. The relative molecular mass of a compound, or MR, is the relative mass of one molecule of the compound on a scale of where the carbon-12 isotope has a mass of exactly 12 units. So it means that same with atomic or relative atomic mass, So this relative molecular mass is also use carbon 12 as a standard. Okay, we can calculate or we can find the relative molecular mass by adding up the relative atomic mass of all atoms present in the molecules. Yeah, depend on the ratio of the atoms in the molecules. For example, for methane, the formula is CH4. So we have one carbon and four hydrogen. So we need to, yeah, we have one carbon and four hydrogen. So we just multiply each number, yeah, with the AR of the element. So it means the 1 times of AR carbon plus 4 times AR hydrogen. Then we add them together and we got MR of methane, which is 16. Yeah, usually we take the value of AR, the whole number value of AR. Yeah, for example, for carbon is 12.01, so we can take the decimal one decimal places here. For example, only 12.0. Okay, this is for the molecular mass of compound or MR. It means that this one is for molecules or for compound. Uh, the other one, yeah. Okay, relative formula mass. Yeah, this one is used for ionic compound. Yeah, it means that the compound that contains ions. We use the term relative formula mass, but we have the same symbol. Yeah, it is still MR. Yeah, and then the way we calculate also similar to MR for relative molecular mass. So for example, for magnesium hydroxide, the formula is MgOH2. So it means in the molecules, or sorry, in the compound, they have ions, one Mg2 plus and 2 times OH minus. So the we add the AR value, yeah, multiply by H atoms or H ions. So it means that 1 times ArMg plus 2 times in the bracket AR oxygen plus AR hydrogen. Okay, so should be 1 times 24.3 plus 2 times in the bracket 16 plus 1. So the result is 58.3. Okay, so that's how you calculate MR. Okay, that's all for today. Yeah, see you next time. Don't forget to subscribe, comment, and like this video so we can learn together and I can create another video to cover your AS and A level study. Okay, thank you very much. Goodbye.